Hey, all right. Hello, geometry students. We're going to go ahead and get started with section 2 of chapter 3, 3.2, talking about the angles formed by transversals. And that was where we kind of learned the names of the different types of angles within a transversal, the same side interior, same side exterior, corresponding, etc. But now we're going to learn what they're what's special about those different relationships, what kind of secret information you can deduce once you can learn to identify those types of angles within a transversal. So first of all, two definitions, and they're actually not new definitions, they're just review, but they're concepts you're going to want to have strongly in mind to to understand 3.2. One is parallel lines, and that is, we defined that last lesson actually, two coplanar lines that never intersect. So we can draw a simple example of parallel lines. Okay, they never intersect, they go on forever. So even if there was a slight difference, those second two are not parallel because eventually out here they would intersect. So those can't be parallel. So we have our parallel line. A lot of times we think of something like railroad tracks, which I guess aren't as common as they used to be, but that's a great example of parallel lines. These lines on a piece of graph paper, those are nice little parallel lines. And the last thing I want to point out is there's a special notation that whenever you see lines in a geometry book, if they have these little chevrons or little arrows in the middle, that is the book telling you you can know that they are parallel. So if you typically don't see two lines and you don't see those little arrows, it doesn't matter which way they're going, then you can't infer unless it tells you that they are in fact parallel. So that's your indication, just like the little vertical lines mark congruency, or the little box in an angle means right angle. These little arrows or chevrons mean the two lines are parallel. Okay, supplementary angles. You should already know what that is. They're two angles that form a linear pair and add up to 180 degrees. So you've got your linear pair looks like so. And then you have like this. And then you know that angles 2 and 1 add up to 180. Angle 1 plus angle 2 equals 180 degrees. Okay? And that's the kind of the key thing, that one thing to point out is whenever lines intersect, you immediately have four sets of supplementary angles, or four sets of linear pairs. Because you can see, if I'm going to just number these, I can see that, put even another color, 1 and 4 form a linear pair. So I know that 1 plus 4 equals 180. I know that 1 and 2 are a linear pair. They add up to 180. 2 and 3 are a linear pair. They add up to 180 because, again, there's a straight line right there. You've got the straight line here and the line coming off it, okay? And then, of course, the last pair, 3 and 4, are linear pairs, okay? So every intersection of straight lines immediately creates multiple sets of supplementary angles. And we're going to see that plays heavily in today's lesson. Okay, so let's look at our questions. This time, more questions than definitions. Okay, so question number 1. Sorry, I forgot to pull up. Let me read them. Question number 1 says, if two parallel lines are cut by a transversal, which sets of angles are congruent? So here's the whole key to today's lesson. We have the transversal from 3.1. The thing they've added is that if the two transversal lines are parallel, so see, look at these beautiful red chevrons. I know that if I even name them, line A and line B are parallel. Then I can know that certain sets of angles are in fact congruent. The ones that you know are congruent are in fact some of the ones we learned yesterday. So first of all, I'll just point out, I know that all vertical angles are congruent. There's lots of those. 1's congruent to 3, 2 is congruent to 4, 5 is congruent to 7, 6 is congruent to 8. Okay, so we're going to put that down. All vertical angles are congruent. Alrighty, but we're also going to be able to know that all corresponding angles are congruent. I'm not going to prove that in this video, but just if you even look at the shape of the angles, you'll notice all these angles are either an obtuse angle or a smaller acute angle, less than 90. Well, to go ahead and take a look at the corresponding 1 corresponds with 5. They are the exact same angle so long as lines A and B are parallel. So 1 and 5 are the same. 3 corresponds to 7. They would be the same. 2 corresponds to 6. They're the same. I'm not saying all these angles are the same, but each pair that I'm circling that is corresponding, 4 and 8 also, they are all congruent. So immediately, if I have parallel lines, I know that a bunch of these angles are congruent to each other. The other two things that I know are congruent are alternate interior. And this one I'm going to abbreviate so you can get used to, we can abbreviate these. Alternate interior angles. So interior are these 4 angles in between, in the middle. And I know that angle 4 is congruent to angle 6 because they're both on the interior and they're on alternate sides. So 4 and 6 are the same. And the same thing as 3 and 5. Okay. So actually, what I want to do here is start giving an example of each one. So let's go ahead. So for vertical angles, and give an example. So like angle 1 is congruent to angle 3. Corresponding angles, I'm going to say as an example, angle 2 is congruent to angle 6. And then alternate interior angles, I'm going to say angle 4 is congruent to angle 6. Okay, and there's one last one, and it's also alternate. So you'll see there's a trick to kind of memorizing this, but alternate exterior angles are congruent. Okay, so that means like what in your exterior angles are these, the ones on outside of the parallel lines, 1, 2, 7, and 8. But the alternate side, so 1 is always equal to angle 7. Okay, or angle 2 is always equal to angle 8. So those are always congruent. And I'll give that as an example. We'll just say angle 2 is congruent to angle 8. So you'll see now, armed with this, when you have a certain angle measurement within a transversal, you can quickly identify multiple angles that are congruent. Vertical, corresponding, alternate interior, and alternate exterior. Okay, question number two asks, if 2 lines are parallel and cut by a transversal, which ones are supplementary? So which angles are supplementary? Again, we defined both of these terms. Supplementary means they add up to 180. So first of all, first thing we'll say is all the linear pairs are supplementary. 1 and 2, 6 and 7, 7 and 8, 5 and 8, 4 and 3. Okay, all of those linear pairs are supplementary. So let's put that first. Linear pairs. Okay, and I'll give an example. I'll just say angle 1 and angle 2. And this I'm not going to say congruent because they're not equal. They're supplementary. They add up to 180 degrees. Okay, which other ones are supplementary? Well, we did all the alternates up here, but now the same side interior angles, those two angles, 3 and 6 add up to 180, and 4 and 5 add up to 180. Okay, so all of the same side, and I abbreviate that like this, S-S interior angles are supplementary. Okay, so for example, angle 4 and angle 5. Okay, and you probably have already guessed it, or you looked in your book, and so you didn't even bother watching this video, or you follow along, but the same side, as long as you learn it, I don't care. Same side exterior angles. So 7, another exterior angle that's on the same side of the, and when I say same side, it's the same side of this transversal here. So on the same side of that is 2. 2 and 7 are both exterior. Okay, they're on the outside of these lines, and they're on the same side of that transversal. So 2 and 7, or 1 and 8. They all, either of those combinations, they add up to 180. They are supplementary. So let's see, angle 1, comma, angle 8. These are just examples. I could fill the whole page listing all the possible angles that fall into these categories. Okay, so let's look at question number 3. Question number 3 says, when 2 angles intersect, what do you call what do all the angles formed add up to? Okay, just wanted to point out something that you may have already realized. But when 2 angles intersect, I'll do it right here, or 2 lines intersect, sorry. we don't know necessarily what each of the angles equals, but I know that this angle 1 plus angle 2 plus angle 3 plus angle 4, I know what they add up to. Because, let's take for example, we know that 1 and 2, being a linear pair, add up to 180. And we know that 3 and 4, being a linear pair, add up to 180. So that means this angle is 180, this angle is 180. So that means 180 plus 180 equals, yep, that's correct, 360 degrees. And that makes sense because if you add up all four angles of an intersection, let's see, this got a little messy here. If you add up all four angles there, you can see that it takes you in a complete circle. And a complete circle all the way around is 360 degrees. So just kind of keeping that in mind, if you're ever solving angles within an intersection like this, you kind of know what they have to add up to because it's got to go all the way around, so it's got to be 360. And there's always an intersection also creates two sets of linear pairs, and that's where you get the 180 plus the 180. Okay, finally, we'll wrap things up. Question number 4 brings this home to actually solving expressions. You knew we're going to have to write some equations and get some algebra going. All righty, and so now once we actually begin to solve angles, this one says you have angle A of x plus 3 and angle B of 3x minus 1, and it's described as same side interior angles. Now, if you haven't memorized that yet, what are same side interior angles or alternate exterior? That's where you kind of panic on a question like this because you're like, I have no idea what that means. But once you learn them, you can say, okay, I see what Mr. Mefford drew. They are on the same side of this transversal here, and they're interior angles, right? Yeah, so they're on the inside, this space right here, between those two angles, okay? So that's how I picked it. I could have drawn them both down here and down here. It wouldn't matter. The key idea is that they're same side interior angles. And it's asked, the question asks, what type of angle or type of equation would you write to solve for x? Well, same side interior angles, if I go up and look, same side interior angles right here are, oops, I'm not underlining, but right here, they are supplementary. So that means I know that these two angles, A and B, I know that angle A plus angle B equals, because they're supplementary, 180 degrees. So that means I can now write a meaningful equation. I could say, okay, so that means x plus 1 plus 3x minus 1 equals 180. Hey, you could even justify that. Say, oh, substitution, given substitution. You're learning a lot in this class. And now we could go ahead and solve that equation. If you notice, I didn't actually ask you to solve, so we're not going to. I'm going to just box that. That's my answer. Okay, I know you could probably solve it. If you guys know other people who do solve it, I think it comes out to x is equal to 44.5. Okay, but notice, because I knew what a transversal was and because I knew what same side interior angles had as a relationship, I can write a meaningful equation. So it's building up, and you've got to know these relationships so you can go and actually apply the algebra that you know how to do. The second part of this question says, what should I write if they were corresponding? So what if, in the alternate universe, angle A was here and angle B was here because they were corresponding angles. And this was x plus 1, or I'm sorry, 3. And this was 3x minus 1 because they're corresponding. Well, go check your notes. But corresponding angles are in the category of always being congruent. So that's the key because that tells you, well, that's the type of equation I need to write. If they're congruent, then I know that angle A is congruent to angle B. So I know that x plus 3 equals 3x minus 1. And I could go ahead and solve it that way and find out what x is. So knowing your angle relationships among these transversals is what's going to allow you to then to write the equations in order to properly solve them. Okay, hope you enjoyed that. I'm sure you did. We'll be working on this tomorrow in class, but make sure you take the always take the online quizzes after completing your notes, and I'll see you soon.